Hi there, Mr. Muhammed is here. This is Oxford Complete Mathematics for IGCSE students. Unit 7 is about graphs. 7.2 is about gradient. So gradient is our objective for this tutorial. Simply, gradient is for straight lines. On the straight line, mark 2 points. It's better to mark points with easy coordinates. So mark 2 points. Then the gradient is number of vertical steps over number of horizontal steps. So it's 3 over 1, 2, 3, 4, 5. It's 3 vertical steps and 5 horizontal steps. The gradient is 3 over 5. This line, if you look at it from left to right, it's going up, so it has a positive gradient. If you see some line that from left to right it's going down, it means this line must have a negative gradient. This one works when you have easy coordinates and easy points. But to make this a little bit more related to rules, we can simply pick 2 points. Then for any 2 points on xy axis, the first entry is x and the second one is y. First is x, second is y. Then the gradient, again y's are on the top, 5 minus 2. Because this y is greater than this y, we can say 5 minus 2. Then it's 5 minus 2. In the denominator, we must say 1 minus 5. 1 is the x minus 5. To make this process even simpler, I prefer to do it like this. The 2 points that you mark first on the line, this point is higher, so consider this point as x2, y2. It's just name. And this one is lower, so this is x1, y1. Now the rule to find gradient is always like this. y2 means this one minus y1 over x2 minus x1. It's just like this. y2 minus y1 over x2 minus x1. This result is the gradient. And this way, automatically, it sets the negative or the positive sign for the gradient. As this line is going down, it must have a negative gradient. And as you see here, it is 5 minus 2, which is equal to 3. And 1 minus 5 is equal to negative 4. So this negative, it doesn't matter if it's 3 over negative 4 or negative 3 over 4. Both are equal to negative 3 over 4. So in fractions, when the negative sign is outside the fraction, or when it's in the denominator or the numerator, it's all fine. The fraction is negative. That's it. Now let's move on to the exercises. In this set of exercise, there is no any graph. We just have 2 points. We have the coordinates of 2 points. Then let's do it. Calculate the gradient of the line joining the following pairs of points. It means if we plot these points, plot the points, when you join them, it's a straight line between them. We need to find the gradient of this straight line. Then we don't have to draw or plot or join. We just use the rule to find it. Then it's up to you. You pick which one as x2 and y2. It's better always to pick the bigger coordinates as x2 and y2. And this is x1 and y1. What we need is y2 minus y1. Let's straight away substitute. y2 minus y1. y2 is 4 minus 1 over 5 minus 3. 4 minus 1 is 3. 5 minus 3 is 2. So the gradient of the first couple of points is 3 over 2. Question 2. Let's say these are x2 and y2. These are x1 and y1. Then the fraction looks like this. 5 minus 1. 5 minus 1. And then 3 minus 1. This is equal to 4 over 2. 4 over 2 could be simplified to 2. Done. Question 3. Let's say these are x2 and y2. These are x1 and y1. Now 3 minus 0 over 4 minus 3. 3 minus 0, because it's y and this one is also y. 4 from this point minus 3. 3 minus 0 is just 3. 4 minus 3 is equal to 1. Finally, the gradient of the line between these 2 points is 3. Question 4. Question 4. Let's say this coordinate is x2, y2. This coordinate is x1, y1. Now subtract. 6 minus 3 and 1 minus negative 1. It looks like this. 1 minus, this is from the rule. Negative 1 is this number. Then it will be 6 minus 3 is 3. 1 minus minus 1 is 1 plus 1. It's 2. The gradient of the line between these 2 points is 3 over 2. Question 5. Does it give the exact same answer if we pick the other point as x2, y2 and this one as x1 and y1? Definitely it gives the exact same point, because when you join them, in both cases you get only one straight line between them, and anyhow you find the gradient of this line, it's the same gradient, it's the same number. Now here, this time, let's say these coordinates, this point is the x2 and y2, this point is the x1 and y1. Then we do the same question again. This time we make this one as x2 and y2 and choose this one as x1 and y1. Let's see how does it work. So let's work out the first one here. x2 is negative 2, negative 2 minus 0, and on the top y2 minus y1, negative 1 minus 0. So this gives negative 1 over negative 2. They both negative, so it is just 0.5 or 1 over 2. Both fine. When you see negative on both sides here, up and down, the negatives can cancel each other. But when you see only one negative, there is no any other negative to cancel. The fraction finally stays as negative. But here, the final result is positive 0.5. Now, if we pick this one as x2, y2, and this one as x1, y1, the fraction looks like this. 0 minus negative 1. This minus is from the rule. This one is for the negative 1. And 0 minus negative 2. Minus minus will be plus. 0 plus 1 is 1. Minus minus will be plus. 0 plus 2 is 2. 1 over 2 is surely 0.5. As you see, it gives the exact same answer. So don't worry when you pick one point as x2 and y2 and the other point as x1 and y1, because finally it gives the exact same answer. But why we name them? To make the rule easier to memorize and to make the calculation as easy as possible. Question 6. Now let's say these points are x2, y2, this one is x1, y1. It's all right, it gives the exact same answer. Then we will have 6 minus 5 on the top, 6 minus 5, and then 1 minus 7. 6 minus 5 is equal to 1. 1 minus 7 is equal to negative 6. So the gradient finally is negative 1 over 6. Question 7 and 8 are your tasks. Question 9. What if we have fraction? We just subtract the fractions just like the ordinary fractions. Question 9. Let's say these are x2, y2, this is x1, y1. Then we will have 2 minus 1. And in the denominator, we have 4 over 3 minus 1 over 2. 3 over 4 minus 1 over 2. 3 over 4 minus 1 over 2 could be done with calculator, or you can say 3 over 4 is 3 quarters. 3 quarters. 1 over 2 is half. 3 quarters minus half. What's remaining is just 1 quarter. Or you can find the common denominator, which is 4. The common denominator between 2 and 4 is 4. Then it's subtraction. How 2 becomes 4? Up and down must be multiplied by 2. This one is fine. 2 times 1 is 2. Now 3 minus 2 is 1, and the 4 doesn't change. 2 minus 1 is equal to 1. So we got 1 over 1 over 4. But it's not in its simplest form. It sounds like division. The denominator of this one is 1. Then we have 1 over 1 divided by 1 over 4, because fraction is the exact same thing as division. Then how can we divide two fractions? Keep the first fraction, 1 over 1. Division will be multiplication. Flip the second fraction. 1 times 4 is 4. 1 times 1 is 1. 1 over 4. 4 over 1 is just 4. So finally the gradient of question 9 is 4. It's just some arithmetics with fractions. You can find it in the previous lessons. It's okay if you have fractions. And so decimal. Let's do this one. Let's pick these coordinates as x2 and y2, this 2 as x1 and y1. Now negative 1 minus 1 over 0 minus negative 1 over 2. Negative 1 minus 1, they both negative. We have to add them with the same sign. 0 minus minus will be plus, 0 plus. 0 plus 1 over 2 is just 1 over 2. Negative 2 divided by 1 over 2. In other words, we can see how many 0.5s, how many halves are there in 2. There are 4 halves in 2, and since one of them is negative, the negative stays. To check this answer, we need to divide negative 2 by 0.5, or 1 over 2. It's equal to negative 4. Question 11 is about decimals, but it's the same. 2.5 minus 2 is equal to 0.5. And then 3.2 minus 3.1. 2.5 minus 2 is equal to 0.5. 3.2 minus 3.1 is equal to 0.1. 0.5 divided by 0.1 is equal to 5. So the gradient of question 11 is equal to 5. Let's check the answer. Fraction 2.5 minus 2 over 3.2 minus 3.1. This is 5. 15 has the same idea. Then these are all numbers. They all have the same idea. Here, what if we have letters? When we have letters, we just write them in the rule. Since we cannot simplify, we just leave it. Here, let's pick this one as x2 and y2, this one as x1 and y1. It's okay if you reverse the process. It's the exact same gradient. Then y2 minus y1, negative b minus n over a minus m. That's it. We just leave it like this because they are not numbers. We cannot work out anymore. Or if you pick this one as x2 and y2, you will have m minus a over n minus negative b. It's just like a flip of this fraction. Done. 23, it's again letters, but this time we have 2a here, a here. It doesn't affect the answer much. So let's say these are x2 and y2. These are x1 and y1. Then if we pick this point as x2 and y2, then we say y2 minus y1 f minus negative f. Then x2 minus x1 2a minus a. F minus minus will be plus, so it will be 2f over 2a minus a is a. So that's it, 2f over a. The same thing is applying for question 24 and 25. Let's do 26 because it's like letters and fraction at the same time. Now let's see how can we deal with question 26, and it's the last question for this tutorial. Then what we need, the first thing is a fraction. Okay, and something is missing here. 2 brackets. We cannot have more than 2 apostrophes in 1 point coordinates, so there must be 2 brackets, as you see now. Now, let's say these are x2, y2, these are x1, y1. Then y2 minus y1, d over 2 minus negative d. C over 4 minus c over 2. We can leave it like this, but if the question said simplify, we can do one more step. Minus minus will be plus. D over 2 means half of d. Plus one more d, it will be 1.5d. It means 1d and half. We can say d over 2, or 1.5d, it means d and half of d. And here c over 4 means a quarter. Minus c over 2, the common denominator is 4. Then this one should be multiplied by 2, multiplied by 2. C minus 2c is equal to negative c over 4. Instead of 1.5d, we can also write 3d over 2, because 3 over 2 is 1.5. 3 over 2d or 3d over 2, they are exactly the same. We can simplify it one more step because it's division of fractions. Then keep the first fraction, 3d over 2. Division, which is this fraction here, is division. Division will be multiplication. Flip the other fraction, 4 over negative c. Now multiply. 3d times 4 is 12d. 2 times negative c is negative 2c. Can we write this negative here? Yes. Then we have to erase this. Done. 12d over 2c. As fraction or as an algebraic expression, it's fine. The gradient is this. And since it's fraction, it has equivalents like 12 and 2, they both divisible by 2. We can also say it could be negative 6d over c after we divide by 2. Done. This is the end of this tutorial. I hope you find it easy. Comment below whatever question you have. Thank you for watching.